November 1942. The North African desert trembled under the tracks of a machine that shattered British confidence and redefined armoured warfare. The German Tiger I, a 56-ton monster clad in armour up to 100mm thick and armed with the legendary 88mm gun, had arrived in Tunisia. British tank crews, veterans of years of desert fighting, watched in horror as their shells bounced harmlessly off its glacis plates, while return fire from the 88 obliterated their Crusaders and Grants from ranges they couldn't even hope to engage. The 2-pounder guns that had seemed adequate against Panzer IIIs and early Panzer IVs were suddenly children's toys. Even the newer 6-pounder, rushed into production after Dunkirk and only just reaching frontline units, struggled against the Tiger's frontal armour. British intelligence had predicted heavy German tanks, but nothing like this. The Tiger wasn't just better than British tanks, it was in a different category entirely. Something had to be done, and it had to be done immediately. What the British tankers and anti-tank crews desperately needed was already being rushed to them, a weapon so powerful it would eventually shatter every piece of German armour it faced. But in late 1942, it wasn't quite ready. The gun existed, the ammunition existed, but the carriage that was supposed to hold it was still being developed. So British engineers did what desperate times demanded. They took the barrel of their new superweapon and literally bolted it onto the carriage of a completely different gun, creating a makeshift hybrid that looked ungainly, performed brilliantly, and arrived in North Africa just in time to change everything. This is the story of the Ordnance quick-firing 17-pounder, the most powerful anti-tank gun fielded by the Western Allies during World War II. A weapon that evolved from emergency stopgap to Tiger killer, that transformed American Sherman tanks into Panther slayers, and that put the fear of God into German tank crews from Tunisia to the Rhine. It's a story of British engineering ingenuity, industrial mobilization, and the relentless mathematics of kinetic energy meeting steel armour at velocities exceeding 3,000 feet per second. The 17-pounder's origins lay in British foresight and the harsh lessons of tank versus tank combat. As early as November 1940, before the 6-pounder had even entered service, British designers were already planning its replacement. They understood what many military planners didn't want to admit: that German tank development wouldn't stop, that armour would get thicker, guns more powerful, and that staying ahead of this curve required thinking 2 steps ahead. The requirements were ambitious. A gun capable of defeating any foreseeable German armour at combat ranges, mobile enough to be deployed with frontline units, and powerful enough to remain effective for years. What emerged from the drawing boards was radical. A 76.2mm gun, the same calibre as the famous 17-pound shell used in earlier British artillery, hence the name 17-pounder. But calling it simply a larger gun understates the engineering involved. This wasn't just a scaled-up 6-pounder, it was a complete rethinking of anti-tank gun design. The barrel alone was nearly 14 feet long, providing the extended tube necessary for propellant gases to accelerate the projectile to extraordinary velocities. The breech mechanism was semi-automatic, opening itself after each shot to eject the spent case and speed up the rate of fire. The recoil system had to be massively over-engineered because the forces generated when this gun fired were immense, equivalent to stopping a car travelling at 60 miles per hour in a fraction of a second. By July 1941, 4 pilot models had been ordered. By May 1942, the design was formally approved for service. The gun worked beautifully. In testing, it punched through armour plates that represented the thickest protection on any known German tank. The problem was everything around the gun. The carriage proved to be a nightmare of competing requirements. To handle the 17-pounder's recoil, it needed to be heavy and robust. The split-trail design, where the 2 legs of the carriage spread apart to create a stable firing platform, had to be massive. But massive meant weight, and weight meant difficulty moving the gun without mechanical assistance. The final carriage design tipped the scales at over 3 tons loaded. You couldn't manhandle a 17-pounder into position, like you could a 6-pounder. It required a tow vehicle, either a tracked gun tractor or a heavy truck. But in autumn 1942, as the carriage design underwent final testing and tooling was being set up for production, intelligence from North Africa sent shockwaves through British military headquarters. The Germans had deployed Tiger tanks. The threat wasn't theoretical anymore. It was destroying British armour right now, today, in the Tunisian desert. The 17-pounder had to get to North Africa immediately. The solution was brilliant in its pragmatic simplicity. Take the 17-pounder barrel and breech, mate it with the carriage from the 25-pounder gun howitzer, Britain's standard field artillery piece, and send the resulting hybrid to Tunisia as fast as ships could carry it. The 25-pounder carriage was never designed for such a high-velocity gun. It was built for an artillery piece that lobbed shells in high arcs, not a flat-trajectory anti-tank weapon that generated massive recoil forces with every shot. But British engineers calculated that the riveted construction of the 25-pounder carriage could withstand the abuse, at least temporarily. They were right mostly. The hybrid system worked. It could fire the 17-pounder's armour-piercing shot, and it could kill tigers. What it couldn't do was pretend to be elegant. The breech of the 17-pounder sat much farther back than the 25-pounder's breech, which meant the firing mechanism had to be extended with bolted-on arms to reach it. The whole contraption looked like a field modification done by desperate troops, which essentially it was, except this field modification was designed by professional engineers and produced in factories. The first 100 of these improvised weapons were given the codename Pheasant, officially designated as the 17 to 25-pounder. They shipped to North Africa in early 1943 and saw their first combat in February. The results validated every rushed decision that had brought them into existence. On February 26, 1943, near the Tunisian town of Hunt's Gap, a battery of Pheasants engaged a formation of German Panzer IVs at ranges exceeding 1,500 yards. The 17-pounder's armour-piercing capped shells punched clean through the frontal armour of the German tanks. 3 were destroyed in rapid succession, the rest withdrew. Days later, a Pheasant gun crew scored the first confirmed kill of a Tiger tank by a towed anti-tank gun when they engaged one at 900 yards. The solid shot struck the Tiger's frontal armour, penetrated and detonated the ammunition inside. The Tiger brewed up, its turret lifting slightly from the hull, in the characteristic cook-off explosion that tankers called brewing up. German tankers who had felt invulnerable suddenly weren't. The Tiger could be killed, and the British had the weapon to do it. But the Pheasant was still a stopgap. As guns arrived in Tunisia, proper 17-pounder carriages were completing development and entering production in Britain. By summer 1943, fully developed 17-pounders on their purpose-built carriages were reaching frontline units in Italy and preparing for the inevitable invasion of France. These production 17-pounders were formidable weapons by any measure. The complete system, gun, carriage and ammunition, weighed approximately 4,600 pounds, making it one of the heaviest anti-tank guns in service. The barrel extended 55 calibers, meaning it was 55 times the diameter of the bore, a length that provided exceptional muzzle velocity. The split-trail carriage gave it a traverse of 60 degrees, enough to engage targets across a wide arc without repositioning the entire gun. The shield, a curved plate of armour protecting the gun crew, could stop rifle-caliber bullets and shell fragments, though it was useless against the kind of fire the gun itself dished out. Operating a 17-pounder required a crew of 7, though in practice, many batteries operated with 6 or even 5 when casualties and shortages bit deep. The gun commander selected targets and directed fire. The layer, equivalent to a gunner in tank parlance, aimed the weapon using a sophisticated telescopic sight that provided magnification and ranging marks. 2 loaders worked in carefully choreographed movements because 17-pounder ammunition was heavy and awkward. The shell alone weighed 17 pounds, hence the name, and the complete round with its massive propellant case weighed nearly 40 pounds. Loading quickly required strength, coordination and practice. 2 more crew members handled ammunition supply, hauling rounds from the limber, the 2-wheeled ammunition trailer towed behind the gun, to the loaders. A driver operated the tow vehicle, usually a Morris quad-gun tractor or later an American M3 half-track, both of which had enough power to move the 17-pounder's weight across European terrain. Deploying the gun was a carefully practiced drill. Upon reaching the firing position, the crew would unhitch the gun from the tow vehicle, spread the trails to create the stable firing base, remove the transport locks that held the barrel in place during movement, and connect the elevation and traverse controls. If time permitted, they would dig the gun in, creating a protective revetment that lowered its silhouette and provided overhead cover for the crew. A dug-in 17-pounder was hard to spot and harder to kill, which mattered because German doctrine called for immediate counterfire against any identified anti-tank position. The gun could be brought into action in less than 2 minutes by a trained crew, though doing so under fire while German tanks bore down on your position turned those 2 minutes into an eternity. Once in action, the 17-pounder's performance was extraordinary, but it came with drawbacks that affected crew morale and survivability. The muzzle blast was tremendous. Crews described it as being slapped hard in the chest with every shot, a concussive wave that rattled teeth and over time damaged hearing even with ear protection. The muzzle flash was enormous, a brilliant orange-white flare that revealed the gun's position to any enemy observer within miles. In daylight, this was merely problematic. At night, it was potentially suicidal because the flash destroyed the crew's night vision and created a perfect aiming point for German return fire. The recoil, though managed by sophisticated hydraulic systems, was still violent enough that firing on soft ground drove the trail spades, the shovel-like anchors at the end of the carriage legs, deep into the earth. After several shots, the gun often had to be physically pulled back out of the ground by the tow vehicle before it could be moved. But these were acceptable problems because of what the gun could do. Standard ammunition for the 17-pounder was the APCBC round, armor-piercing capped ballistic capped, a sophisticated projectile that represented the cutting edge of anti-tank ammunition design. The armor-piercing core was hardened steel, heat-treated to a specific hardness that balanced penetrating power with brittleness. Too hard, and the shot would shatter on impact. Too soft, and it wouldn't penetrate. Over this core sat a soft metal cap, usually mild steel that prevented the penetrator from shattering when it struck face-hardened armor. The cap deformed on impact, cushioning the penetrator and allowing it to bite into the armor plate. Finally, a ballistic cap streamlined the projectile, reducing drag and extending effective range. This 3-layer construction gave APCBC ammunition exceptional performance. At 500 meters, the 17-pounder's APCBC could penetrate 163 millimeters of armor plate, angled at 30 degrees from vertical, a standard testing angle that approximated real combat conditions. At 1,000 meters, penetration dropped to 150 millimeters. These figures meant the 17-pounder could penetrate the frontal armor of every German tank in service during 1943 and 1944 except for the King Tiger, and even the King Tiger's frontal plate was vulnerable at closer ranges. The Tiger I's frontal armor was 100 millimeters thick. The 17-pounder could defeat it from over a mile away. The Panther's 80mm glacis plate, sloped at 55 degrees, was a tougher proposition because of the extreme angle, but testing showed the 17-pounder could penetrate it frontally at ranges below 800 meters with APCBC, and side shots could be made at any practical combat range. German tankers quickly learned to fear the crack of a 17-pounder firing. That distinctive sound, sharper and louder than the boom of smaller anti-tank guns, meant someone nearby had just become a target of a weapon that could kill them before they even knew it was there. But the British weren't satisfied with APCBC performance. They wanted more penetration, especially against the heaviest German armour. The solution was APDS, armour-piercing discarding sabot, one of the most innovative ammunition types of the war. The principle behind APDS was elegant. A full-caliber projectile, one that matched the 76.2mm diameter of the gun barrel, was limited in velocity by its weight and the amount of propellant that could be safely burned behind it. But what if you could fire a much smaller, denser projectile at much higher velocity? The problem was that a smaller projectile wouldn't engage the rifling in the barrel, the spiral grooves that spin the projectile and stabilize it in flight. The sabot solved this. It was a lightweight aluminum jacket that surrounded a tungsten carbide penetrator core. The sabot engaged the rifling, accelerating the entire assembly down the barrel. As the round left the muzzle, aerodynamic forces stripped away the sabot petals, and the dense tungsten core continued toward the target at extraordinary velocity. APDS fired from a 17-pounder left the muzzle at approximately 3,950 feet per second, compared to 2,900 feet per second for APCBC. This increased velocity translated directly into increased penetration. APDS could punch through 256 millimeters of armor at 500 meters and 233 millimeters at 1,000 meters. These were devastating figures. King Tiger frontal armor was 150 millimeters thick. APDS could defeat it. No German tank was safe from a 17-pounder firing APDS. But APDS had problems. The first was accuracy. The sabot didn't always separate cleanly from the penetrator, especially in early production rounds. Sometimes pieces of sabot struck the muzzle brake, the device at the end of the barrel that redirected propellant gases to reduce recoil, damaging it and affecting subsequent shots. Even when separation was clean, APDS was inherently less accurate than full-caliber ammunition. At ranges beyond 500 yards, dispersion increased dramatically. A 17-pounder firing APCBC could hit a tank-sized target reliably at 2,000 yards. The same gun firing APDS had dispersion 3 to 4 times greater. This made APDS problematic for long-range engagements. There was also the problem of spotting fall of shot. When an APCBC round missed and struck the ground short of the target, it created a visible impact: dust, smoke, sometimes a spark if it hit stone. The gunner could see where the shot landed and correct his aim accordingly. APDS penetrators, being much smaller, created much less visible impact. If an APDS round missed low, the gunner might not see where it went, making it difficult to adjust aim. British firing doctrine eventually recommended using APCBC for initial ranging shots, and only switching to APDS once hits were being obtained. The third problem was damage. APCBC rounds created large holes and, if they penetrated, caused catastrophic damage inside the target as the heavy projectile tumbled and fragmented, igniting fuel and ammunition. APDS penetrators, being smaller, created smaller holes, and surprisingly sometimes caused less internal damage. The dense tungsten core often passed completely through the target, making a clean hole in one side and out the other without fragmenting significantly. This could leave an enemy tank damaged but still operational, whereas an APCBC hit would more likely cause immediate catastrophic destruction. But APDS was still valuable for its ability to defeat armour that APCBC couldn't, and British doctrine called for 17-pounder equipped units to carry roughly 6% of their ammunition as APDS, the rest being APCBC. APDS didn't reach frontline units until summer 1944, after D-Day. The first APDS rounds arrived in Normandy in late June or early July, just in time for the breakout battles, but even before APDS was available, the 17-pounder with APCBC ammunition was more than adequate for dealing with German armour. As production ramped up through 1943 and into 1944, 17-pounders replaced 6-pounders in Royal Artillery anti-tank regiments across the British and Canadian armies. By June 1944, most anti-tank regiments were equipped with the 17-pounder, though infantry battalions still relied on lighter 6-pounders for their integral anti-tank platoons because the 17-pounder was simply too heavy for infantry to manhandle. But towed anti-tank guns, however powerful, had limitations. They were defensive weapons, excellent for holding ground and ambushing enemy armour, but difficult to use offensively. Moving a 17-pounder forward during an attack meant exposing the tow vehicle and gun to enemy fire, and once deployed, the gun was essentially immobile until the crew could limber it up again, a process that took precious minutes, under fire. What tank units needed was the 17-pounder's killing power in a mobile platform, something that could advance with tanks, engage enemy armour on the move, and then relocate quickly. The British had known this since before the 17-pounder entered service, and they had plans for multiple self-propelled and tank-mounted versions. The first attempt was the cruiser tank Mark 8 Challenger, a British design based on lengthened Cromwell tank components, with a larger turret specifically designed around the 17-pounder. The Challenger was a disappointment. It was tall, making it an easy target. It was mechanically unreliable. It was slow to produce. Only 200 were built, and they entered service too late to significantly impact the Normandy campaign. A more successful self-propelled version was the Archer, which mounted the 17-pounder on a Valentine tank chassis. The Archer was unusual because the gun faced rearward. The vehicle would drive into position, fire rearward from cover, and then drive forward to escape without having to turn around. This worked surprisingly well in practice, and Archers served effectively from late 1944 through the end of the war. The British also converted American M10 tank destroyers, replacing their 3-inch guns with 17-pounders. These conversions were called Achilles, and over 1,000 were produced. The Achilles provided mobile anti-tank firepower for Royal Artillery regiments, though the M10's open-topped turret made crews vulnerable to artillery airbursts and overhead threats. But the most important and influential 17-pounder platform was neither British-designed nor purpose-built. It was a field expedient that became one of the most feared armoured fighting vehicles of the war, a hybrid that combined American industrial capacity with British firepower to create something greater than the sum of its parts, the Sherman Firefly. By early 1943, the British Army was receiving large numbers of American M4 Sherman tanks through Lend-Lease. The Sherman was a good tank, reliable, well armoured by 1942 standards, and armed with a 75mm gun that was excellent against soft targets, but increasingly inadequate against the newest German tanks. British tankers needed better firepower, but British tank production had focused on the Cromwell, which was fast but lightly armoured and armed with the same 75mm gun as the Sherman. The Challenger was in development but struggling. The obvious solution was to put the 17-pounder in the Sherman. The Ministry of Supply's Tank Decision Board rejected this idea. They believed British tank designs would soon replace the Sherman entirely, making any conversion effort wasted resources, but two Royal Tank Regiment officers disagreed. Major George Brighty and Lieutenant Colonel George Witheridge had combat experience, and they knew that survival in tank versus tank combat came down to who could penetrate whose armour first. The Sherman's 75mm couldn't penetrate a Panther frontally. The Panther's 75mm could penetrate a Sherman from any angle. This was an equation that killed British tankers. Through persistence, technical demonstrations, and the grim arithmetic of combat losses, Brighty and Witheridge convinced the skeptics. By late 1943, a working prototype existed. An engineer named W.G.K. Kilbourne at Vickers had solved the seemingly impossible problem of fitting the 17-pounder into the Sherman's turret. The 17-pounder had a recoil stroke of 40 inches, far too long for the Sherman's turret. Kilbourne completely redesigned the recoil system, placing shorter cylinders on both sides of the gun instead of underneath it, taking advantage of the turret's width. He rotated the breech 90 degrees so it opened to the side instead of downward, allowing the loader to work from the left side of the turret. The radio, normally mounted in the back of the turret, was moved outside into an armoured bustle box welded to the rear of the turret, and the hull machine gunner position was eliminated, the space used for ammunition stowage, reducing crew from 5 to 4 but increasing ammunition capacity to 75 rounds of 17-pounder ammunition plus machine gun ammunition for the hull-mounted Browning. The result was cramped, awkward, and brilliant. The Firefly could do what no other Allied tank in service could do. It could kill Panthers and Tigers from the front at combat ranges. In October 1943, Winston Churchill himself declared the Firefly the highest priority for British tank production. Even before final testing was complete in February 1944, an order for Tussas 100 Fireflies was placed. Production began in January 1944. By May 31st, 342 Fireflies had been delivered to the 21st Army Group for the Normandy invasion. The Firefly went ashore on D-Day, June 6, 1944. Its first combat action actually occurred at sea, firing from landing craft toward German fortifications while still offshore. The first tank regiments to land with Fireflies were the 13th 18th Hussars at Sword Beach and Canadian regiments at Juno Beach. Within hours of landing, Fireflies were engaging German armour. The impact was immediate and dramatic. British tank troops, the equivalent of American platoons, were organised with 3 standard Shermans armed with 75mm guns and 1 Firefly. The Firefly typically hung back slightly, using the other Shermans as spotters and decoys, while positioning itself to deliver killing shots with the 17-pounder. German tankers quickly learned to recognise Fireflies by their distinctively long barrels and prioritised them as targets. In response, Firefly crews began applying camouflage schemes to disguise the gun's length, painting false muzzle brakes halfway along the barrel and counter-shading the forward section with white paint to make it appear shorter from a distance. The distinctive long barrel became both the Firefly's greatest advantage and its greatest vulnerability. British tank doctrine around the Firefly emphasised its role as the heavy hitter. Standard Shermans would advance, draw German fire and manoeuvre for flank shots while the Firefly remained in hull-down positions, only the turret exposed, waiting for Panthers and Tigers to present themselves. When they did, the 17-pounder spoke. German after-action reports from Normandy contain repeated references to encounters with long-barreled Shermans that destroyed panthers and tigers from ranges that shouldn't have been possible. On June 14, 1944, Sergeant Harris of the 4th 7th Dragoon Guards achieved one of the most remarkable feats of gunnery in the Normandy campaign. Near the hamlet of Longève, his Firefly engaged 5 panthers in rapid succession, destroying all 5. Harris would fire, then immediately relocate to a different position, preventing return fire. Reload, fire again, relocate. 5 panthers destroyed in perhaps 10 minutes, each shot a kill. This was the Firefly demonstrating what it was designed to do. The most famous Firefly action, and one still debated by historians, occurred on August 8, 1944, during Operation Totalize. SS Hauptsturmführer Mikl Wittmann, the most successful tank ace in history with over 130 confirmed kills, was leading a counterattack with Tigers from the 101st Heavy Panzer Battalion. His force encountered British and Canadian armour near the village of Sintho. What happened next lasted only seconds, but it ended one of the most feared careers in armoured warfare. Trooper Joe Eakins, gunner in Sergeant Gordon's Firefly from the 1st Northamptonshire Yeomanry, had positioned his tank in an orchard with good fields of fire. At approximately 1,247 hours, Eakins spotted Tiger tanks moving across open ground. Range approximately 800 metres. He engaged. His first shot struck a Tiger in the turret side, penetrating and causing a catastrophic ammunition detonation. The Tiger erupted in flames. Eakins traversed to a second Tiger, fired, hit, another kill. The third Tiger was attempting to manoeuvre when Eakins fired again. Penetration. Explosion. 3 Tigers destroyed in perhaps 90 seconds. One of those Tigers was almost certainly Mikl Wittmann's. German records confirm Wittmann's Tiger was destroyed at that time and location. British gun camera footage and after-action reports match Eakins' account. While some historians have suggested other possible causes, including fire from Canadian Shermans or a rocket-firing Typhoon aircraft, the most likely scenario supported by the evidence is that Trooper Eakins, firing a 17-pounder from a Sherman Firefly, killed the Tiger ace. It was the Firefly doing exactly what it was designed to do, leveraging British firepower and American reliability to defeat German heavy armour. The Germans feared the Firefly. Tactical instructions to panzer crews specifically called for engaging long-barreled Shermans first, before other targets. A standard Sherman might damage your tank. A Firefly would destroy it. Throughout the summer of 1944, Firefly production continued to accelerate. By the end of August, 550 had been built. By February 1945, another 1,500 had rolled off the conversion lines. Total production reached approximately 2,000 to 2,100 vehicles, making the Firefly the most numerous tank mounting the 17-pounder. But the Firefly had limitations. The 17-pounder was designed as an anti-tank weapon, optimized for firing armor-piercing shot at high velocity. High explosive shells for the 17-pounder existed, but they were weak. The shell walls had to be thick to withstand the firing stresses, leaving less room for explosive fill. The 75mm gun on a standard Sherman fired a high explosive shell with 1.47 pounds of explosive. The 17-pounder's HE shell contained only 1.06 pounds. This made Fireflies less effective against soft targets, infantry, gun positions, fortifications, things that tanks encountered more often than enemy tanks. A late-war development improved the HE shell by reducing propellant charge and using thinner shell walls, but even improved HE was inferior to the Sherman 75's capability. This is why British doctrine called for mixed troops. 3 Shermans with 75mm guns for general-purpose work, infantry support, fortification busting, and 1 Firefly with the 17-pounder for killing tanks. It was a balanced approach that played to each weapon's strengths. The other limitation was visibility and comfort. The 17-pounder's muzzle blast, tremendous even in the open on a towed mount, was intensified inside the confined space of a tank turret. Firing the gun created an enormous flash that could temporarily blind the gunner and commander even with their eyes closed. After a few shots, the muzzle flash often ignited vegetation in front of the tank, creating smoke that obscured visibility. The massive recoil, even with the redesigned system, made the entire tank rock backward with each shot. Crews described it as being inside a drum that someone hit with a sledgehammer. and the cramped interior meant the loader was working in extremely confined conditions, manhandling 40-pound rounds in a space barely large enough to swing them around. Despite these challenges, or perhaps because crews understood their survival depended on this gun, Firefly crews loved their tanks. They knew they had the only Allied tank that could reliably kill Panthers and Tigers frontally. They knew German crews feared them. They knew their squadron mates depended on them for firepower that standard Shermans couldn't provide. The Firefly served until the war's end, participating in every major British and Canadian operation from Normandy to the Rhine crossing. It equipped Polish, South African, and New Zealand armoured units. American forces, initially sceptical, requested Fireflies in August 1944 after experiencing the Panther's superiority over the 76mm armed Sherman, but production constraints and supply priorities meant few, if any, reached US units during the war. Post-war, Fireflies served with numerous nations including Belgium, India and Poland. Some remained in service into the 1950s. The Firefly represented what military historians call a successful field expedient, a solution to an immediate problem that ended up being so effective it became standard equipment. It proved that sometimes the best answer isn't waiting for the perfect purpose-built weapon, but adapting what you have to meet the threat you face. Meanwhile, the towed 17-pounder continued to serve throughout northwest Europe. On D-Day, 6 17-pounders were landed by glider to provide anti-tank defence for British airborne troops who had seized key bridges and strong points inland from the beaches. These guns were flown in on Hamilcar gliders, the only Allied glider large enough to carry a 17-pounder and its tow vehicle. Landing a multi-ton artillery piece by glider at night behind enemy lines required exceptional courage from both the glider pilots and the gun crews. But those guns provided critical firepower that helped British airborne forces hold their positions against German armoured counterattacks. As the campaign in Normandy progressed, 17-pounders proved their worth repeatedly. In the close terrain of the bocage, the Norman hedgerow country, their long range was less important than their ability to penetrate heavy armour at any angle. A 17-pounder positioned behind a hedgerow, almost invisible, could wait until a Panther or Tiger came within a few hundred metres and then deliver a killing shot before the German crew even knew the gun was there. German intelligence reports from July 1944 specifically warned about British anti-tank guns capable of penetrating Tiger frontal armour at over 1,000 metres, a clear reference to the 17-pounder. The gun's effectiveness created a grim form of respect. German tank crews who survived encounters with 17-pounders described the weapon with a mixture of admiration and fear. One captured Panzer officer, interrogated after the war, stated that the 17-pounder was more dangerous than any other Allied anti-tank weapon, including the American 90mm gun, because it was more common and because British gun crews seemed exceptionally well trained. This wasn't German propaganda or Allied exaggeration. It was the reality of a weapon that could defeat any German armour from any angle at any practical combat range. As Allied forces broke out of Normandy and pursued retreating German armies across France and into the Low Countries, 17-pounders accompanied every armoured and mechanised formation. During Operation Market Garden in September 1944, the failed attempt to seize bridges across the Rhine in Holland, 17-pounders provided crucial anti-tank defence during desperate fighting. At Arnhem, British airborne troops held for 9 days against overwhelming German forces, including heavy armour. The few 17-pounders that had been landed by glider accounted for multiple German tank kills before being destroyed or abandoned when ammunition ran out. The gun's performance was so impressive that even after the war, the 17-pounder remained in service far longer than most World War II-era weapons. It served in Korea, where British and Commonwealth forces used it against North Korean and Chinese armour, and, surprisingly, found it effective as an indirect fire support weapon against bunkers and fortified positions. The 17-pounder's flat trajectory and ability to penetrate earth and timber fortifications made it useful in ways its designers never anticipated. The gun wasn't replaced in the anti-tank role until the late 1950s, when recoilless rifles and wire-guided missiles took over. As a tank gun, the 17-pounder was succeeded by the 20-pounder, a purpose-designed 84mm weapon that equipped the Centurion tank. But even as technology moved on, the 17-pounder's influence persisted. It established the principle that firepower and the ability to penetrate enemy armour mattered more than almost any other tank characteristic. It proved that upgunning existing vehicles was often faster and more effective than waiting for new designs, and it demonstrated that the combination of a powerful gun, well-trained crews, and sound tactical doctrine could overcome apparent disadvantages in armour and mobility. The 17-pounder's development timeline is worth considering. Design work began in late 1940. Formal approval came in May 1942. First combat use was February 1943. The Firefly variant entered combat in June 1944. From concept to frontline deployment in less than 4 years, despite a world war diverting resources and disrupting production. This was possible because British designers made practical choices. They didn't chase perfection. They accepted that the gun would be heavy, that it would have tremendous recoil, that it would be difficult to conceal. They focused on what mattered, penetrating German armour, and they succeeded brilliantly. The numbers tell the story. Total 17-pounder production exceeded 15,000 guns in all variants, towed, self-propelled, and tank-mounted. These guns served with British, Canadian, Australian, New Zealand, South African, Polish, and other Allied forces. They participated in every major campaign from Tunisia through the final defeat of Germany. They accounted for thousands of German armoured fighting vehicles destroyed. Against Tiger tanks, the 17-pounder achieved a kill ratio that exceeded any other Allied anti-tank weapon. British after-action analysis from 1944 showed that 17-pounders accounted for over 60% of Tiger tanks destroyed by British forces, despite representing a smaller percentage of total anti-tank weapons deployed. This ratio reflected both the gun's capability and tactical doctrine that prioritised using 17-pounders against the heaviest German armour. Against Panthers, the most numerous German heavy tank, the 17-pounder was equally effective. Penetration testing conducted by British and American forces on captured Panthers confirmed that APCBC ammunition could defeat the Panther's frontal armour at ranges below 800 metres and side armour at any range. APDS could penetrate Panther frontal armour at all practical combat ranges. The Panther was designed to be nearly invulnerable frontally to existing Allied guns. The 17-pounder negated that advantage. Perhaps the best indication of the 17-pounder's effectiveness comes from German reactions. German tactical manuals from late 1944 specifically warned about British anti-tank guns and long-barreled Shermans. German radio intercepts recorded numerous instances of tank commanders reporting encounters with weapons they couldn't counter. One intercepted transmission from December 1944 during the Battle of the Bulge included a Panther commander reporting, "We are taking fire from British anti-tank guns. These are not 6-pounders, penetration at over 1,000 metres, requesting artillery support." The Germans had extensive experience fighting Soviet 85mm and 100mm guns, American 90mm guns, and their own captured weapons. The 17-pounder impressed them more than any of these. Soviet 85mm guns were common and effective, but had less penetration than the 17-pounder. American 90mm guns, used in the M36 tank destroyer, had comparable penetration but were far less numerous. The 17-pounder combined Soviet-level prevalence with penetration that exceeded anything short of dedicated tank destroyers. The gun's longevity also speaks to its design quality. Many World War II weapons became obsolete quickly after the war as new technologies emerged. The 17-pounder served for another 15 years, not because there was nothing better, but because it was good enough and available in large numbers. The British Army's post-war austerity meant keeping effective equipment in service as long as possible, and the 17-pounder remained effective throughout the 1950s. Israeli forces captured Fireflies from Egyptian forces during the 1956 Suez Crisis and were impressed by their firepower. The Centurion tank, armed with the 17-pounder's successor, the 20-pounder gun, dominated Middle Eastern tank warfare for decades. The design philosophy established by the 17-pounder, powerful gun, proven chassis, effective ammunition, continued to guide British tank development through the Cold War. But beyond statistics and technical specifications, the 17-pounder's real significance was human. It gave British and Commonwealth, tank crews and anti-tank gunners confidence that they could fight German heavy armour on equal terms. Before the 17-pounder, encountering a Tiger or Panther meant manoeuvring for a flank shot or calling for air support, because frontal engagement was suicide. After the 17-pounder arrived, those encounters became battles that British forces could win. Trooper Joe Eakins, the Firefly gunner who killed Michael Whitman's Tiger, was a 22-year-old kid from Northamptonshire. He wasn't a super soldier or tactical genius. He was a well-trained gunner with a weapon that could do what needed doing. That was the 17-pounder's real gift. It turned average soldiers into tiger killers. The gun also represented British engineering at its pragmatic best. While German engineers pursued perfection, creating the Tiger II with its 128mm gun, and King Tiger's nearly impenetrable armour, but also its 69-ton weight and mechanical unreliability, British engineers created a weapon that was good enough, deployable in large numbers, and effective against all threats. The Tiger II was arguably the best tank of the war. Only 492 were built, and mechanical problems kept many out of action. The Firefly was an expedient conversion of an American tank. Over 2,000 were built and they served reliably throughout the war. Which approach was better? The results speak for themselves. The psychological impact on German crews cannot be overstated. Early in the war, German tank crews had enjoyed technical superiority. The Panzer III and IV were better than most Allied tanks they faced. By 1943, the Tiger and Panther had restored German technical advantage, but the 17-pounder took that advantage away. A German tanker in a Panther knew that any Sherman might be a Firefly, that any hedgerow might conceal a 17-pounder, that the armour they relied on for protection could be defeated at ranges where they couldn't effectively return fire. This fear affected tactics. German armour became more cautious, less willing to press attacks when British forces were known to have 17-pounders in position. The gun's mere presence shaped the battlefield even when it wasn't firing. Crew accounts from both sides provide insight into what combat with 17-pounders was like. Sergeant Gordon, the Firefly commander whose gunner killed Whitman's Tiger, described the engagement as clinical. Eakins spotted them, ranged, fired. I saw the hit. The Tiger brewed up immediately. Next target, same result. It was what we trained for. The 17-pounder did what it was supposed to do. On the German side, survivors of 17-pounder engagements described terror. One Panther commander, captured after his tank was destroyed by a Firefly, said, "We never saw it. One moment we were advancing, the next there was an explosion and everything went white. My loader and gunner were killed instantly. The driver and I bailed out. The Sherman that killed us was 500 meters away, behind a wall. Its gun was enormous. We didn't stand a chance." These accounts repeated across hundreds of actions. The 17-pounder firing first, usually hitting first, usually killing with the first hit. The combination of a powerful gun, good optics, and well-trained crews created a weapon system that dominated its role. As the war entered its final months, the 17-pounder continued to prove its worth. During the Rhine crossing in March 1945, 17-pounders provided Overwatch as assault forces crossed the river, engaging German tanks and fortifications on the far bank. In the final battles in Germany, as ammunition supplies became critical for retreating German forces, 17-pounders exploited German logistical collapse. Panthers and Tigers immobilized by fuel shortages or mechanical failure were destroyed methodically by advancing British forces. The gun that had entered combat in February 1943 was still killing German armour in May 1945. The 17-pounder represented the right weapon at the right time. It arrived when German armour superiority threatened to stall Allied offensives. It provided firepower that could defeat any German tank. It was produced in sufficient numbers to equip frontline units, and it remained effective throughout the war. In military history, such weapons are rare. Usually there's a gap between when a weapon is needed and when it arrives, or it arrives in insufficient numbers, or it works in testing but fails in combat. The 17-pounder avoided all these pitfalls. It was rushed into combat as an improvised mount in early 1943. By June 1944, it equipped hundreds of tanks and towed guns. By war's end, it had destroyed more German heavy armour than any other Allied weapon. The story of the 17-pounder is ultimately a story about problem-solving. The British identified a problem, German heavy armour, and developed a solution powerful enough to address it. When the standard mounting wasn't ready, they improvised with a pheasant. When they needed mobile firepower, they created the Firefly. When they needed more penetration, they developed APDS. At every stage, British engineers and commanders adapted to circumstances and delivered solutions that worked. This adaptability was as important as the gun's technical capabilities. The 17-pounder's legacy extended beyond World War II. It established design principles that guided post-war anti-tank weapon development. The emphasis on muzzle velocity and kinetic energy, rather than explosive power, became standard for armor-piercing ammunition. The concept of mounting powerful guns in medium tank chassis, proven by the Firefly, influenced the design of main battle tanks that combined firepower with mobility. The lessons learned from APDS ammunition development led to modern armor-piercing fin-stabilized discarding sabot rounds that arm every modern tank. Even the tactical lessons remained relevant. The principle of mixed gun types in tank units, combining specialized tank killers with general-purpose vehicles, influenced Cold War tank doctrine. NATO forces during the Cold War organized units with a mix of anti-tank specialists and multi-role vehicles, directly descending from British Firefly tactics. At the Imperial War Museum in London, a Sherman Firefly sits on display, its long 17-pounder barrel extending far beyond the Sherman standard profile. Visitors often photograph it, sometimes without realizing what made this tank special. It looks like a Sherman with a bigger gun. But that bigger gun changed armoured warfare. It meant German Panthers and Tigers were no longer invulnerable. It meant British tankers could fight on equal terms. It meant that Allied industrial capacity and engineering ingenuity could overcome German technical advantages. At the Royal Artillery Museum, a towed 17-pounder sits preserved, its split trail splayed, barrel elevated at a neutral angle. The gun hasn't fired in decades, but its presence still conveys power. The size of the barrel, the robust construction of the carriage, the massiveness of the breech mechanism all communicate that this was a serious weapon designed to do serious work. From North African deserts to Norman bocage to German industrial heartland, the 17-pounder shattered German armour and shattered German assumptions about their technical superiority. It was the right gun at the right time, fired by the right crews, and it changed the war. When British tankers and anti-tank gunners heard that crack, that distinctive sharp crack of a 17-pounder firing, they knew something on the far end of that trajectory was about to have a very bad day. And when German tankers heard it, they knew death had come calling.